All right, guys, back with number 3. So we have this set up. I'm as sure as I can be of anything that this will be on the test. They seem to do one all the time like this. So we've got g of x equals integral from 2 to x of f of t. So if we were to take g's derivative, so if we take the derivative of this side, we would get f of x. So this picture here of f could also be called a picture of g prime. So that's g's derivative. So simple as can be. So it says, does g have a relative min, a relative max, or neither at x equals 10? So g does have a critical point at x equals 10, but since g prime, or f, goes from negative to 0 back to negative, that is a saddle point, so neither a max nor a min. It says, does a graph of g have a point of inflection at x equals 4? So a point of inflection is a point where the second derivative changes signs. So second derivative is the slope of this picture, goes from positive to negative. Doesn't matter if there's a corner point there. That will affect things going forward, but not backward. So that would be an inflection point at x equals 4 because g prime, the slope of g prime or g double prime changes signs. C says find the absolute minimum value and the absolute maximum value of g on negative 4 to 12. Okay, so whenever we're finding absolute max and absolute min, we have our candidates. So those are endpoints and critical points. So there is a possibility at negative 4, critical point at negative 2, critical point at 2, but that's not a max nor a min, so I'm going to skip it. 6, 10, also not a max or a min, so we'll skip it, so go to 12. And then I know before I go that at negative 2, that is only a possibility of being a min because it's going slope from negative to positive, negative values to positive. And at 6, that's only going to possibly be a max. So if we're going to find values, we have to use this here. So we're starting, at 2. So if we want to find g of negative 4, we'll do the integral from 2 to negative 4, which I don't like, so I'm going to do negative the integral from negative 4 to 2. So flip it around, change its sign. Okay, so let's count these. So this area right here is an area, it's a 2 by 4, so it'll be 4. And then this area here is 8. So if I were going from left to right, that'd be negative 4 and 8, so that'd be 4. But since I'm going from right to left, that'll have to be negative 4. So the value at negative 4 is 4. Then this area takes me down 4, so this will be a negative 6. And then if we're going to do g of 6, we'll go g of 6 equals the integral from 2 to 6. So 2 to 6, that's an area of 4 by 4, so 8. So that'll take me 8. And then we can just keep counting from 6 to 12. So this will take me back down 8, so I'll be back at 0. And this will take me down 4, so that'll be at negative 4. Okay, so I have an absolute minimum of negative 6 at x equals negative 2. I have an absolute max of 8 at x equals 6. I know those are the ones because those are all my candidates, and that is the biggest y value and smallest y value. So let me see, this says that negative 2. Oh, that should have, sorry, I did mess up here. This was g of negative 4 was negative 4, and that takes me down 4. So this should have been a negative 8, not a negative 6. Sorry. Okay, so then it says for negative 4 to 12, show all the places where g of x is less than or equal to 0. So we have a 0 value right here. So we're positive, we're coming back. So we'd be negative from 10 to 12. So definitely from 10 to 12. And then here, if we think about this, takes me up from left to right, but from right to left, it takes me down. So if we were at 0 here, we'd be at negative 8 here, and then we'd be at negative 4 here. So we're negative that whole time. So from negative 4 to 2. So from negative 4 to 2, and then again from 10 to 12. Not a great explanation. If you need more help on that, I can provide it. Thanks.